So right now I'm live. Actually, a small glitch was there, technical glitch, but now that's been sorted out. We are starting this crash course. As I can see, sir, is this crash course enough to score marks in casting? Yes, Varun, this will be enough. This is going to be enough for you. You need not to do anything else. Crash course, that will be enough. Yes, apart from this crash course, you will have to. Voice is not coming, is it? Just a minute. No, it's coming, right? Now okay, right? Fine. Okay. Chalo. So we are starting this casting. Two main kind of casting processes are there, as you know. One is what you call as sand casting, and another one special casting processes. So the most of the syllabus in casting is of sand mold casting, right? Or simply you call it as sand casting. So we are starting with this sand casting, right? Let me first tell you the basics of sand casting. From there, the part that I'm going to discuss. From here, they ask mostly 1 mark question. So this is going to be very much important. Today's session will be fully dedicated to 1 mark question on basics of sand casting, and then we'll move further ahead. You see, when you do the sand molding, basically you melt the molten metal, right, in some furnace, and then with the help of sand and some other additives like clay, water, some cereal binder, you make the mold. So this is how the mold looks like. There will be a mold cavity, let us say down here. This is your mold cavity. Fine. And this mold cavity is made with the help of, as all of you know, something called as pattern. Suppose you have to make this cavity, I will explain. You take the pattern and then you ram the sand over it, and once ramming is complete, we take the pattern out from there. Yes, we take the pattern out from there. And suppose if you want a hollow section into the casting, you also use this, something called as core. Yes, I'll explain this, don't worry. Then molten metal should reach there, that must reach there. For that, what you do, you cut several channels into the sand mold. Yes, those channels are named like differently. This channel, the vertical channel that just now I am drawing, is what you call as sprue, right? And then at the bottom of a sprue, there will be a cup shaped cavity, the way I have drawn, and there the cup will be placed, and it will be like a ceramic cup. And then, as you see here, the cavity will not be like a straight one. It will have some, you know, convexity on the inner surface. Like this, the convexity will be there. And then you will have this straight portion, and thereafter you will have something like this, that is also a cavity. Actually, let me show you. Something like this will be there. A spherical cavity will be there here. This, a spherical cavity will be there, and then similarly the channel will keep moving towards this side, and then here you will have another cavity, I'll come to that cavity, don't worry, just hold on. Yes, and then dear students, we will have this cavity here, and thereafter the channel will further move towards right hand side like here, and then there will be one opening right here like this. This is the whole system that you use in sand casting, and I will explain the systems one by one. Don't worry, just hold on. Let me beautify it a little. थोड़ा सा सुंदर दिखेगा तो आपको अच्छे से समझ में आएगा. डायग्राम्स का सुंदर दिखना ज़रूरी है, राइट? And sorry I became late a little because a technical glitch was there. I was unable to capture whatever I'm drawing. That's what happened actually, right? So stay with me one by one. What am I going to do? I am going to discuss every single thing. Not only this casting chapter, whole production will be completed here itself. That too well before GATE exam. That too well before GATE exam, my dear. Yes. That too well before your GATE exam. You see. So just you will have to come to the class daily 7:30 to 8:30 p.m. You will keep getting the notifications in a Telegram group. The name of that Telegram group is actually Mech Army, MECHARMY. You can just search this group in Mech Army, like in Telegram, MECHARMY, MECHARMY, Mech Army, and you can join this. Here you will have the updates. Here you will have updates. Whatever I am teaching here on YouTube or special classes, that update you will be getting here. Let me keep the background black itself. Now, here there is something like this funnel shaped cavity which will be placed over this. Something like this will be there. Yes. This. Look at this. One more thing will be there. I hope you will be knowing this that I am drawing. This is what? A dead weight will be placed here. A dead weight will be placed here. Like you put a brick, right? Now, let me explain it one by one. This is what that you are seeing here is your molding flask, right? This is whatever you are seeing here is your molding flask. This is in two parts. One is on the top, another one is the bottom part. So the top one is what we name as cope, and the bottom one is what we name as drag. If suppose the molding flask is made into three pieces. Yes, this is the first lecture, Ankaj. This is the first lecture. So this is cope, this is drag. If it is made in three pieces, and sometimes you need to make it into three pieces. कभी कभी ऐसा होता है कि इसको तीन पीस में बनाना होता है. कब तीन पीस में बनाना होता है? जब ये कास्टिंग जो अंदर कर रहे हो ना, इसका शेप अगर काफी ज्यादा कॉम्प्लेक्स हो, ये जो कास्टिंग हम अपने बनाने वाले हैं काफी कॉम्प्लेक्स हो ना, तो केवल दो पोर्शंस में अगर बनाओगे ना तो वो कैविटी कॉम्प्लेक्स यहाँ पे आपको दिख नहीं पाएगा, और जब तक ये कैविटी कॉम्प्लेक्स नहीं होगा तब तक कास्टिंग कॉम्प्लेक्स आप कास्ट नहीं कर पाओगे. सो for that purpose, my dear, sometimes it is made into three pieces, and if you made it into three pieces, then the middle one is what you call as cheek. That's a very basic knowledge everyone knows. Now what happens, I am giving you something that you will understand new. Cope, cheek, drag. Yes, very nice Akshay, very nice, awesome. And keep coming to these classes. I am going to cover whole production very beautifully. You need not to go anywhere else. You see, this is what you call as pouring basin. You know, you can either impress the pouring basin there. What is here, you know, dear? What is here? What is this all? This is sand mold only, right? This is sand mold only. Sand plus clay plus water, whatever is here. So, if you use your finger and press a little, सो यू कैन मेक अ फनल शेप्ड कैविटी, फनल के तरह का कैविटी हाथ से भी प्रेस करके, अंगूठे से प्रेस करके बना सकते हैं। एक तो वो कर सकते हो, दैट विल ऑल्सो बी कॉल्ड एज पोरिंग बेसिन। दूसरा, अगर वो नहीं बनाना है हमें, सेकेंडली इफ यू डोंट वांट टू, now today there is no special class, I will be commencing a special class like from tomorrow or day after tomorrow, okay acha? So what we do here, we place and a special class mein pyq series will be regular, that will be continued. So either you press it and make it like a skim bob, sorry, like a pouring basin, or you can do another thing here. This pouring basin, which is like a funnel shaped cavity, will be made somewhere else, and then like from ceramics you can make it, and you can simply place it over here, over this vertical channel that you have cut into the sand mold, which is what you call as sprue. This vertical channel is what you call as a sprue. Why do we put this pouring basin here? The reason is, when you pour the molten metal directly, if you pour the molten metal directly here my dear, directly here, so surrounding is what? In surrounding there is sand mold, yes, and you don't want those sand mold to break and to mix with the molten metal. If you pour directly, the flow will be highly turbulent, and that may break the sand mold into the surrounding. Yes, my dear, that may break the sand mold into the surrounding. Whatever surrounding sand mold is there, that may break, and then it can mix with the molten metal and will reach the casting cavity, and here in this cavity, if it solidifies, the casting will become defective. So to regulate the flow, it should like not be turbulent. This is first poured, molten metal is first poured into this pouring basin, and then the molten metal enters this vertical channel, that is what we call as sprue, with almost laminar behavior, and the sand mold surrounding this vertical channel, surrounding this sprue, does not break out, doesn't mix with the molten metal. Now listen very carefully, because this concept that I am going to discuss now is really very much important. You see, here we place a filter inside the sprue. This filter which I am showing you there, it looks like, have you seen the coin of carom board game like this? And there will be, suppose, these small holes in it. This is what is placed here. This is what we call as a strainer. This is what we call as strainer. What is a strainer? Strainer is basically a ceramic filter. Strainer is actually a ceramic filter. Now, when you are pouring the molten metal here into this channel, what may happen? You see, the molten metal that you are pouring may have impurities. Now, whatever impurities are there, in those impurities, few impurities will be like larger in size, few impurities will be like a smaller in size, and few impurities will be like too small in size. Yes, size differences of impurities will be there. Here in the first stage filtering in the sprue channel itself, here in the first stage filtering in the sprue channel itself, you place, to do this first stage filtering, you place this something called as a strainer, which is like a carom board coin having a small holes, not large holes. Yes, it has like a small holes, but this small hole cannot be too small so that it filters very small impurities. Why? Because if you made these होल्स टू स्मॉल इन साइज, अगर बहुत छोटा साइज का बना दिया तो जानते हो क्या होगा? मोल्टेन मेटल जब यहां आप पोर करोगे तो लाइक मोल्टेन मेटल, इफ दीज होल्स बिकम टू स्मॉल, बिकॉज यू वांटेड टू फिल्टर द too small, so small impurities there, then what will happen? Molten metal will not come down with a continuous flow. It will start coming down like drop by drop, and that is how you cannot fill the cavity. Yes, so these holes are basically not too small. It is small but not too small, right? It is only that much small so that out of the smaller and larger impurities, it can only filter the larger impurities. Because if you want to filter smaller impurities, then the holes there that you are making should be even smaller than this. Then only it will be filtered, and then the problem will happen over the over the over the strainer. These impurities will start to deposit like this, that to smaller impurities, and later on you will not be able to make the molten metal pass through it. So that problem will happen. So what does a strainer or ceramic filter does? It only filters the large size impurities. It cannot filter out a smaller size impurities. Why can't it filter out a smaller size impurities? Because if you want to filter a smaller size impurities with the help of this strainer, those holes that you are making will have to be made larger in size. And if you make it smaller in size, and if you make it smaller in size, what will happen? Impurities will start to deposit at the top, and then molten metal will not pass through it. It will like jam over there. Yes, that you don't want. So this is the first stage of filtering that we have done here. This is the first stage of filtering that we have done here. Molten metal actually undergo 3 different stages of filtering. मोल्टेन मेटल में 3 डिफरेंट स्टेज में फिल्टरिंग होती है. वो कैसे कैसे होती है मैं समझाऊंगा. बहुत इंपॉर्टेंट कॉन्सेप्ट है. नाउ लिसन केयरफुली माय डियर, होल्ड योर ब्रेथ एंड लिसन. Molten metal comes down, 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 down. Now when it falls down here, it will have a lot of kinetic energy because it is falling down from there. So it will have a lot of kinetic energy. If here the sand mold is there in the surrounding, what may happen? If suppose this is a sand mold, this sand mold will erode. This sand mold will erode. Because of that too high kinetic energy, a lot of turbulent flow will be there. So it can erode, it can mix with the molten metal. ये erode हो जाएगा sand mold, यहाँ से molten metal के साथ mix हो जाएगा. molten metal के साथ अगर mix हो जाता है तो क्या होगा? Defective बना देगा casting को. तो यहाँ पे हम क्या करते हैं? At the bottom of the sprue, this is the bottom of the sprue, we place something called as this something called as ceramic splash core. And this is like ceramic. Here also ceramic. Why? Because ceramic is a highly refractory material. It will not melt or burn or fuse under the high heat of the molten metal that you are pouring. That's why a strainer also made out of ceramic. This splash core that you are placing here is also made out of what? Ceramic. Because ceramic is highly refractory. Yes. Now my dear students, listen. Here as the molten metal reaches here, then from here it is going to change the direction of the flow. And as all of you know, whenever any liquid, it changes the direction of the flow. It changes the direction of the flow. Like molten metal is flowing here, and once it reaches here, it will flow. It will change the flow direction. So during the change in the flow direction, the metal undergoes this contraction. If suppose you made your cavity like this, like here where the metal is changing the direction of the flow, and you keep this portion straight, molten metal will undergo this much of contraction. Now as the molten metal is undergoing this much of contraction, what will happen? This much of area that you are seeing will remain vacant. इतना जगह क्या रहेगा? इधर खाली रहेगा. ये जगह क्या इतना इधर खाली रहना चाहिए क्या? अगर ये जगह यहाँ खाली हो गया तो जानते हो प्रॉब्लम क्या होगी? In the surrounding here, what is there? In the surroundings, what is there? Sand mold. And as all of you know, sand mold है तो sand grains है, और sand grains है तो sand grains क्या होगा? Porous होगा. उसमें क्या होगा? अंदर ऐसे ऐसे पोर्स होंगे, है ना? और इन पोर्स के थ्रू like air can go in, air can come out. So what will happen? As the molten metal is flowing down there and this contraction happens here, yes, this contraction will happen because the flow direction is changing and this area remains vacant, white color one. This area remains vacant. So here air will come, yes, and that air may dissolve. That air may dissolve into this molten metal, and if that air dissolves into that molten metal, what will happen? This molten metal along with air will reach this casting cavity. If it reaches this casting cavity, air along with metal, if it reaches the casting cavity, the air will first try to come out. But suppose if the air does not come out and the casting solidifies, after solidification of the casting, take the casting out and take an x-ray of that casting. When you will take the x-ray of the casting, you will find these things there, like these cavities, small cavities. It can be like spherical in size or it can be like elongated in the size. So these are actually defects, gaseous defects, like blowholes can form, blisters can form, pinhole porosity can appear. These are all gaseous defects that occur due to the entrapment of air particles, vapor, burnt gases inside the casting. So my dear, air must not reach the casting cavity. If air has not to reach the casting cavity, then first thing is air must not dissolve. That's why instead of making, that's why my dear students, instead of keeping this section straight, what do? We provide this much of compensation. Means sand mold will be made like this here, this type impression. This is what we will be doing. So what happens actually, you look at this. This is how here the portion will be made, and this is what we call as, this is what my dear students we call as compensation for, this is what we call as compensation for vena contracta. This that you are seeing is what we call as compensation for vena contracta. Now your molten metal moves in this direction, yes, and then your molten metal reaches here, yes, in this section. Here is what the second stage filtering will happen. There is what the second stage filtering will happen. And how does this second stage filtering happen? Let me now discuss. This second stage of filtering occurs into this spherical cavity, and this spherical cavity, my dear students, is what we name as a skim bob. This is what, this spherical cavity is what we name as a skim, S-K-I-M B-O-B, skim bob. What is this skim bob? What is this skim bob? This is a spherical cavity that we cut into this horizontal channel. Dear students, what happens? Here already, let me show you. Here already large size impurities were filtered. लार्ज साइज इंप्योरिटीज वर फिल्टर्ड. यहां पे लार्ज साइज इंप्योरिटी को पहले ही आपने फिल्टर कर लिया था. नाउ हियर द इंप्योरिटीज व्हिच आर देयर, it's going to reach here, that will be smaller in size. Now out of those smaller impurities, few impurities will be there which will be lighter in weight, and few impurities will be there which will be heavier in weight. There will be few impurities here which will be lighter in weight. There will be few impurities here which will be heavier in weight. Those impurities which are larger in weight will float in the upward direction. Those impurities which are larger will float in the upward direction, and those which are heavier will settle down. Yes, those which are lighter will flow in the upward direction, and those which are heavier will settle down. These impurities will be entrapped here into this spherical cavity known as a skim bob. So here what happened? Second stage filtration happened. Yes, very nice, awesome dear. Now the molten metal will flow, and now from here it will enter the original mold cavity. So this section that you are looking at here, from where the molten metal is entering the cavity, is what we call as simply gate, or it is also called as in gate. So it enters that cavity through the gate or through the in gate, my dear students. Now listen what happens. Molten metal entered. So as the molten metal is entering the cavity like this, suppose this inside what have been placed is called as core. Whatever we have placed here, this is what we name as core, C-O-R-E. This is what we call as core actually. Core is made out of the same material of which the sand mold is made out of. This core is made out of the same material of which this sand mold is made out of, but the properties of this core metal will be relatively better as compared to the sand mold surrounding it. And yes, it must be better. Why? Because this is the core. This is the core, which is like a smaller in size, less metal is there, and moreover, from all sides it is surrounded by the molten metal. From all sides it is surrounded by the molten metal. So yes, whatever this core metal is there, it should have better refractoriness. Whatever this core metal is there, it should have better strength, both green strength and dry strength. It should have better collapsibility. Yes. Now, that part of discussion will again come. But here happened the first stage filtration. There happened the second stage filtration. Here in the skim bob, molten metal reached here, and then molten metal, did not fill into this much of part because here core was there. So now what will happen? Now what will happen? You see, now the remaining metal will start to rise. You see, will start to rise into a cavity that we have made just beside the original mold cavity. The rest of the molten metal will now start to rise into this cavity. Yes, it is rising. Since the molten metal rises in this cavity, listen carefully, since the molten metal rises in this cavity, since the molten metal rises into this cavity, that's why, my dear students, it is called as riser. Everyone knows this is riser, but no one give it a damn that why is it called as a riser, yaar. This is called as a riser because molten metal, rest of the molten metal now rises into this cavity. What is the purpose of the riser? I'll come to you, I'll explain to you, don't worry. You see, as the molten metal reached here, my dear students, then undoubtedly this molten metal, its temperature will start to decrease. Initially the temperature of the molten metal will be too high. This will be even higher than the temperature of the molten metal will be even higher than the melting temperature, because the molten metal has to be poured from here, and then it is traveling through these cavities, and then it is going to reach here, and then it is going to fill this cavity. It is going to take time. So if you simply melt the metal, you keep it at Tm melting temperature, you pour it, what will happen? The metal will start to solidify. The metal will start to solidify long before it reaches the original mold cavity. Do you want that? No. If the molten metal does not reach the mold cavity, what is the benefit, yaar? You will not get anything, yaar. Yes. So the molten metal, when it is poured at temperature. It is poured at a temperature which is far above than the melting temperature, and that temperature we will be naming as pouring temperature. So let me take another slide and let me explain this to you really very beautifully. Listen carefully, dear, what is happening. You see what is happening. Here, when you pour the molten metal, the temperature of the molten metal was too high. It was like how much? Pouring temperature. This temperature is too high temperature. This temperature is your pouring temperature, and you will have to pour the molten metal at this very high temperature so as to enable sufficient fluidity to the molten metal. Yes, if fluidity is less, it will not be able to reach and fill the cavity properly. Now, dear student, as it fills here, when the molten metal fills here, listen very carefully, this is a very important part that I am going to discuss. Its temperature will start to reduce. It will start losing the heat into the surrounding, yes, and this will start to cool down, not solidify. This will start to cool down, and its temperature will start to reduce, and this temperature will reduce and will reach a temperature, that is what we call as this melting temperature. Once the molten material there in the cavity reaches the melting temperature here, then solidification will begin. Then solidification will start. Then solidification will begin. It will not end, it will begin. Yes, solidification begins. As the solidification begins, and it takes some time, and solidification occurs. Once the solidification occurs, and then let us say that temperature that you are getting after solidification there into the casting is what? TF. TF means freezing temperature. Then this freezing temperature will also be very high as compared to that of the room temperature. Yes, just to solidify casting, it will still be red hot. Its temperature will not be melting temperature, it will be below melting temperature, but far above the room temperature. Yes, now it will further cool down, and now its temperature will reach something called as room temperature. This, let us say, ambient temperature, T naught. Now, my dear, listen carefully what's going to happen. Once the temperature of the molten metal itself within the casting, within the mold cavity, is reducing from Tp to Tm, from pouring temperature to melting temperature. Once the temperature is reducing from Tp to Tm, what will happen? The liquid metal will undergo some amount of contraction. The liquid metal will undergo some amount of contraction, and that contraction is what we also name as shrinkage. That contraction is what we also name as shrinkage. Here, this is the first stage of shrinkage. That is what going to happen. First stage shrinkage, and technically this first stage shrinkage is happening into the liquid state itself. When the temperature is coming down from pouring to melting, then this first stage, this contraction, this volume reduction is happening into the liquid state itself. So my dear students, this is what we name as liquid shrinkage. Now, my dear, once the temperature reaches Tm, here already some volume reduction occurred. When the temperature reduced from pouring to melting, some volume reduced. Whatever the molten metal in the cavity was there, its volume reduced. Similar thing will happen when it solidifies. It solidifies in which temperature range? In this temperature range, that is between Tm to Tf. And once it is solidifying, again there will be some reduction in volume, except one case. I will tell you, don't worry what case. In this stage, that is second stage shrinkage will happen. And during this stage, what is happening? When the temperature is falling down from melting to freezing, actually liquid phase is changing into the solid phase, during which what I am saying, there is a volume reduction. That reduction is a shrinkage, which is named as, my dear, phase change shrinkage. This is what we name as phase change shrinkage. Dear students, I told you, in most of the cases, in all the cases, let us say, whatever material you take, it is, the shrinkage, the second stage of shrinkage, the phase change shrinkage is going to happen in such a way that volume will reduce, except one case. And that exception is a gray cast iron. That exception is a gray cast iron. These two stages of shrinkage, its nature is always going to be, what? Contraction. There will be volume contraction. Only one exception is there, and that exception is gray cast iron. To know the region, join me in engineering materials classes. There I will explain the perfect region. Why does gray cast iron, instead of all the other materials, their volume reducing, its volume increase? Gray cast iron, this actually expands during the second stage of shrinkage. By the way, all the other materials will only undergo contraction. So if the volume is contracting, my dear, and you allow that contraction, and you don't compensate for this contraction, what will happen? You wanted a casting of like this size, and you will end up getting a casting is smaller in size. You will get dimensionally, defective casting. So when the volume is reducing, that reduction in volume must be compensated. How is it compensated? In the first two stage, when it is like here, it is liquid, and here also it's liquid, but now it is changing towards solid, and here at this temperature it is going to become fully solid. So these two stages, that is the first two stages of shrinkages, which are mostly like contraction in nature, are compensated by what? Compensated by riser. Riser. Yes, I had shown you the riser just now into the diagram. This is compensated by the volume shrinkage. Then in the first two stage, it is compensated by riser. How exactly riser compensates for the first two stage of shrinkage? Very simple, my dear students. When the volume is reducing here, then whatever liquid metal which has risen into this cavity while filling this mold cavity, that will come back and will compensate for whatever the shrinkage is happening into the first two stage, Now listen carefully, my dear. If it is like a gray cast iron, it is going to expand. What we will be doing, if you are casting gray cast iron, don't use the riser, because you need not to compensate. So why to use this riser? Using this riser means you don't make, you make this cavity. Not using this riser, you don't make this cavity, right? Now, dear students, listen carefully. Actually, my mobile phone has switched off, so I can't see what you are writing in the comment sections. Yes, but I can ask for some other phone if you allow, so that I can see what chit chat is going on into the comment section. Suraj, तो छोटी का फोन बोलो तो देने के लिए. Yes, now listen carefully, dear students. मोबाइल फोन एक आ गया. अब मैं देख सकता हूं क्या हो रहा है in the comment section. This video. Hmm? Restricted mode. Something else is happening. Rajeev Singh. Just hold on, dear. Casting. Casting part 1. No, no, no. Not this. Because if I can see your comments, then it looks good. I even don't know what channel is this on which I am teaching. I can't find it. Okay. I don't know how to restrict the disable mode. They're asking to come on, man. Tomorrow I will have my battery charged and I will be watching your comments. Don't worry. Listen. So what I was saying, if gray cast iron is being casted, don't use the riser. That's it. No problem at all. Yes? Now, what happens? This metal has already solidified. This metal has already solidified. Already solidification has taken place. Temperature has reached. Oh my God. I erased it. Oh, it came. Come on. Now, when the temperature has reached freezing temperature, it is still at a very high temperature. So further, the temperature will go down to room temperature. And you know, during this, that is during this cooling process as well, there will be shrinkage. And that shrinkage is what we call as third stage shrinkage. Now it has already solidified. Solidification has occurred. And this is what we name as solid shrinkage. And here also I am going to explain a very beautiful concept. Here also I am going to explain a beautiful concept. Listen very carefully, dear. You know, mostly my dear students, mostly this shrinkage, that is that they're in third stage, will have a nature of contraction. Means when the solidified casting, which is at higher temperature, its temperature reduces, this nature of the shrinkage will be mostly contraction. Will be mostly contraction, my dear students. It is going to contract. Mostly contraction. But sometimes, you know, expansion can also happen. Contraction and then expansion can also happen in some cases. You know, when will the expansion happen? Expansion if the materials are like this, which are being casted. If the material is your silicon or germanium or bismuth or antimony, if you are casting these materials now and you have already casted it, it has solidified, and now from that freezing temperature, the temperature is reducing towards the ambient temperature, then instead of getting contraction, it will expand. So all these things, expansion of gray cast iron during the second stage and expansion of these four metals, silicon, germanium, bismuth, antimony, in the third stage is due to their microstructures and microconstituents. So for that we need to understand some basics of the engineering materials. So whenever I will be teaching engineering materials, or if you are there on the plus, or you take the subscription, you can contact me, and there I will tell you how to understand this very concept, that what is exactly happening. Now, if the contraction is happening, that contraction will have to be compensated. Yes, otherwise the casting will become dimensionally inaccurate. So, this material has already solidified. Yes, this material has already solidified here. This gate is closed, isn't it? So even though if molten metal is here in the riser, that molten metal cannot come back and cannot compensate for shrinkage. So what we do, we know that okay, lengthwise like 2 mm contraction happened, some widthwise 1 mm contraction happened, thickness wise some 1 mm contraction happened. So why not to make the cavity itself lengthwise 2 mm larger, widthwise 1 mm larger, thickness wise 1 mm larger, so that even though it contracts, the casting comes to its original size. And that means you are making the cavity larger. How to make the cavity larger? By making the pattern larger, because this is the pattern that you keep there and over which you put the sand and you ram it and then you take the pattern out, you have the cavity left into the sand mold. So why not to make the pattern itself larger, lengthwise 2 mm, widthwise 1 mm, thickness wise 1 mm, and you take the pattern out, cavity will be larger. So even though in the third stage contraction is happening, already you had taken care of, you had compensated that contraction, that third stage of shrinkage, with the help of what? Oversized pattern. You made the pattern larger in size. Oversized pattern will compensate. Oversized pattern will compensate this third stage of the shrinkage. Oversized pattern will compensate this third stage of shrinkage. Yes, dear students, oversized pattern will compensate for the third stage of the shrinkage if it is contracting. That is, this oversized pattern is what we tell, making this is what we tell that we are taking positive shrinkage allowance. We are taking positive shrinkage allowance. But in this case, when expansion is happening, what will you be doing? You will be making undersized pattern, because expansion is going to happen. So what you will be doing, instead of making the pattern larger, we'll be making the pattern smaller. So even though if it expands, it comes to its original size. So you are going to make the undersized pattern, and making this undersized pattern is what we call as taking negative shrinkage allowance onto the pattern. Taking negative shrinkage allowance onto the pattern. Taking negative shrinkage allowance onto the pattern. Yes, dear students. Do you guys have any doubt up till this? Do you guys have any doubt up till this? I hope you guys will not have any doubt up till this. Hold on. This YouTube. I don't know how to disable the restricted mode settings. Accessibility. General. So okay, no problem. In this session, I discussed you these basics of casting. I told you to join a Telegram group. I even told you to join a Telegram group. Yes. Okay, one more thing happened. You guys would have some problem in watching this. Yes. Let me just change its position. Now you can see whatever I had discussed. Yes. Now you can see. Yes, I can see. You can see. Yes. This is what I had written there. Na? This came down. I was not watching live, na? So I didn't know that this happened. I'm sorry. Chalo, but you can now see whatever I have written here, because I have kept my video, myself on the top. Myself, I was there on the bottom. Yes. And yes. So what I said you is you want all these things, notifications of my special classes and YouTube classes, you can join this Telegram group Make Army. Moreover, if you want to subscribe, so whenever you subscribe for plus courses, I will be available there to help you out in whatever matter you want. You always use this referral code RK007. That means you came from my referrals. Yes, and if you further find any problem, you can always feel free to call me on this number. If I'll be in class, I'll cut the call and call you back. Okay, 76759 That's my number. And myself, Rajeev Singh. I am shaping the young minds like you for past 10 years. I am a plus educator on an academy platform, and yes, I am the magician of mechanical engineering. You will keep seeing these magics of medical, especially the production engineering, the manufacturing engineering in the upcoming classes. Once we reach there on the completion part, you will also become a magician of manufacturing, believe me. And this session is going to be, all these sessions are going to be very important, very important for your upcoming GATE exam. So yes, remember this James Bond RK007 referral code, note down this number to call me and join this Telegram group Make Army. All my students are there. Now you are also my students, you will also be there. So guys, let's meet tomorrow sharp at 7:30. See you. Right? Bye bye. Good night. I'm sorry today I was unable to see your chat and comment because my phone switched off. Tomorrow I'll charge and I will set that so that I can even see your comments and chats that's going on. Right? Chalo. Tomorrow sharp 7:30.